thanks for joining me. Welcome back to the channel, and thanks to everyone who's watched my previous few videos, liked, commented, subscribed. It's really appreciated. The interest in the Beast Car project, it's helping motivate me to carry on with it and keep making more videos as well. So thanks for that. In this video, I'm going to go into what the damage was from the ROSSA event and what caused it and what actually had gone wrong. I'm going to talk about the learnings that I had from the event and what I'm going to do differently next time. Then I'm going to talk about what my future plans are for the Beast project, which I think will be quite enlightening, and you'll get an idea of what my future videos are going to be about. So keep an eye out for that later in the video. So let's get on with it. Hi, I'm back in the garage. I'm going to take the Beast car out of the bin bag today and see how much of it's salvageable. Let's have a look. Oh dear, what a mess. So what's the damage then? There's only one speed controller that's actually still looking fully intact and still attached to the power distribution unit. So in a minute I'm going to power that one up and see if it actually works. So I've got it hooked up to the laptop via the flight controller, and it seems to be that the flight controller is still alive, which is great. Now I'm going to plug in the battery and see if any of the speed controllers are still within this Well, I'm trying to turn the motors. There was only one plugged in, so even if it worked, only that one would be going, and it doesn't seem to do anything. I can only hear the very slightest click as I try and turn them, so I can only assume that this one is also kaput. Never mind. Now I've got everything apart, I can really see the true scale of what happened here. I mean, everything's black in here from the soot from what burnt. There's bits of speed control. I think these are the MOSFETs, or sorry, was the MOSFET. So that's the inside of that. Then if we come over here, this is the remains of the two speed controllers that were the worst burnt. One of them looks like it might be salvageable, but I'm not sure. Then the PDU plate. The PDU itself looks okay because it had the flight controller on top, and then underneath that you can see where there was a lot of fire going on. Basically, in any areas where it was exposed, it's got a big layer of soot on that. Anyway, so I've got it apart. The power side is there, flight controller side is there. Next, I'm going to just take all the suspension apart and get the motors off the car so they're ready to be tested. Well, there we have it, the Beast car back down to its constituent parts almost. I've got the motors removed there, ready to go for some testing. All the burnt and slightly less burnt parts from the electronics there, and these are the suspension systems. One thing that was a bit surprising is anywhere where the bolts got hot or
even seemed, just seemed to be where the fumes from the fire were going past them. They've all gone very rusty. Must have taken the coatings off the bolts or something. Quite interesting there. Best avoided these fires if you can.
You may remember from the ROSSA Round 3 video that I released a couple of weeks ago that the first problem I had with the Beast car was that I burnt out 2 of the motors on a test run. So what I've done is taken the data off the car from that, it's logged in the flight controller, and made a couple of graphs from it to try and understand what actually happened. The first graph I've got, it shows the percentage throttle applied to the left and right motors of the car, and we can have a look at how that varies as the car steers. So if we compare it to the footage from that test run, we can see some initial throttle applied when the car pulls away, followed by some left motor throttle when I do a right turn. Then I'll do a left turn, so it's only throttling the right motors. Then a little bit of straight before another right turn, so it's only the left motors driving at that point. Then in a straight line, the throttle is quite low, that's required to do that. And finally, the left turn there, so I've got only the right motors driving until they burnt out, basically. So what does this graph tell us? Well, to me, it tells us that as it's turning, it's only the outside motors that are being throttled, which isn't that surprising, really. Especially when I was actually using the mechanical brakes to brake the inside wheels as the outside ones were trying to drive. So now let's go on to the next graph I've got, which is to do with the current being drawn by the power distribution unit and the GPS speed. So again, you can see these peaks that they line up to where I'm doing the cornering, and the current goes up to nearly as high as 140 amps. So 140 amps times the 12 cells is about 4 kilowatts. So it was pulling some quite high power, and I know that, yeah, that would have been split over only 2 motors, and at low RPM the brushless motors can get a bit of a hard time if you're asking them to deliver a lot of torque. There'll be a lot of current going through it, which is then what's overheated the motor coils and caused them to break down and turn into magic smoke, as we saw in the video there. So we can get a bit of learning from that, and that's basically that I've been trying to make the motors work too hard at low RPM to do those turns, which has then overheated the motors and caused them to burn out. Interestingly, this graph also shows the maximum speed achieved so far by the Beast car, which is just under 16 miles an hour, so still got a long way to go there. So as we've just seen, the first learning is not to overload the motors at low motor speeds. The next one is I need to turn up with a more proven powertrain, and also bring spare motors and speed controls anyway, because you never know what's going to happen at the event. And I know I said I never wanted to rewind a motor again, but I should also bring spare stator wire just in case I gets in a sticky situation with too many burnt out motors. And once I've rebuilt them, I should have a way of checking their kV value, so what their RPM per volt value is, that is. Finally, I suppose a summary of all of those is that I shouldn't be taking a car to ROSSA again that I haven't already shown can go, stop, steer and brake reliably. The next set, there's more.
I'm not quite sure
first
how to
one
help
is,
you with that.
yeah, thanks Alexa. The first of the second page of learnings is that the car just needs to be easier to work on. Changing the motors, adjusting the ride height should be much more straightforward. And really it was the suspension system that was making that difficult, so potentially I could eliminate that, because as I mentioned before in previous video, the car would still run without suspension, but it won't run if I haven't been able to fit replacement motors to it. The next one is I should add a service hatch so that power can be connected and disconnected more easily. 10 screws to take the body off isn't really practical in emergencies, and to do things quickly. The next one's an interesting one, radio and run protocols. I need to have two clear modes for slow and high speed running, and to make them idiot proof, and make sure I learn them properly as well. I mean, I found when you're actually going to do your speed run, you tend to be quite on edge and a bit excited, and things just go out of your brain. And I, like for example, on my second run with the beast car, I forgot to disarm it while I travelled back from where I put the car on the track to where I actually took the run from. And somehow in that time, the throttle got knocked and went up to 60%, and then ultimately set the speed controls on fire and caused the failure of the car. I did some investigation afterwards, and I found some settings on my transmitter seem to give some unexpected results. Like if I move the switch that I've got set up to give the throttle delay, it's a 3-position switch. The first position was off, second position was with the throttle delay, the third position shouldn't really have done anything, but I found that if I flicked it into that position, the throttle went to 50%. And I didn't set that up, so I need to go through everything on that transmitter setup and make sure there's no unintended operations going on. So all of that is wrapped up in that learning there, really. And the final one I've got is a bit of a learning from the cone runs that I did at ROSSA Round 3, where I did have one really successful run where the car didn't veer to the left at all, probably because I didn't go over the bumpier part of the track. So next time, if that happens again, I should be looking back at the footage from that and doing what I can to replicate that, which I didn't actually do on the day that time. So having taken on board all these learnings, the next thing for me to do is work out what to actually do next to progress the Beast Car project. And I've got 2 ideas for that. Firstly, I'm going to add mechanical steering to the car, which makes me a bit sad to say, because I really love the simplicity of having no steering and just relying on the variable motor speed to carry it out. But what I found was at lower speeds, it's putting massive loads into the motors and then causing them to overheat. So if I can add mechanical steering just to help it turn without putting that load into the motors, then it's going to help me out. And it could give me more control options. It could mean that I could control the car as it actually does the speed run, either with or without the mechanical steering. And it could help me go faster as well, because the steering at the moment, where it slows down one set of wheels, speeds up the other one, that on a 100% throttle run, that can only work if you actually lift off the throttle on one side, which will slow the car down. So it might actually help me go faster. I might look at adding that to the cone as well, even though I found it doesn't need it, just to enable me to test and learn about the mechanical steering system and how to set it up in advance of the event. So the second one is to build a powertrain test rig. So my idea is to build some kind of test rig that's going to allow me to put the powertrain through its paces, but only testing one motor and speed controller at a time, so that I can do it in safety, and in the worst case only blowing up one motor and speed controller instead of all 4. So next in the video, I'm going to go into a bit more detail on those 2 ideas and show a bit of CAD of where I've got to with them. So we're back in Onshape. Onshape's got this really useful feature actually, where you can save a previous version of your design, and I've done that with the Beast Car and the cone. So as I move to make a slightly new version of it with mechanical steering, I can preserve my previous design, so that isn't going to be lost. I quite like that feature. Anyway, hopefully you've got over the shock of the fact that I'm adding the mechanical steering, because I'm going to show you how that's going to work now. I've left the body on because it shows the problem that I've really got with adding the mechanical steering. I want to keep the body the same because I've already made 2 of them. But as you can see from the rear suspension, there's very little clearance between the side of the wheels and the inside of the bodywork. So how am I going to get some steering angle on the front wheels with that clearance limitation? So what I'm actually going to do is bring the wheels inwards slightly, so you can see here there's a little bit more clearance there. That's going to allow me to get around 5 degrees of steering angle, which I've calculated by fairly simple calculation. Should give me about a 12-metre turning circle, which on a big runway would be fine. It's quite a simple calculation. The turning circle is related to the turning angle of your steered wheels and the length of the wheelbase of the car. So let me show you what I'm going to do for the mechanism. So firstly, I'm going to slice this car so we can see inside it. Right, so I've got my section set up there. You can see I'm sliced about halfway up through the wheels, where the wheels are, because you can see the axle of the motor there. The motor bolts to these blocks here, which pivot on this block here. I'll show that again in a sec. I'm just showing the clearance issue at the moment. I can take my steering block here and turn the steering a little bit, and you can see that there's actually plenty of clearance on the outside. On the front, on the outside, on the other side it's a little bit closer, and any clearance issues I've got on the chassis I can just take a little bit of material off the chassis to allow for that, so I don't feel worried about that. I think that's going to work. So I'll get it straight again and show the, if I hide the body, turn off the section view, then I can show my basic design of the mechanism. So it's going to have this quite blocky steering block piece, and then this sort of bulkhead at the front there, with which the steering blocks pivot on. The precise details I haven't ironed out yet. This I like to show my working, so this is an early stage of what my idea is for the steering. There's a lot of detail work to go into this still. Somewhere around here there'll be a servo, and that will then attach to this crossbar here with a little link, and that'll then push the steering blocks to and fro together. You can see it's freed up quite a bit of space here, so I've got options here. I could move the batteries forward, or just leave it as it is. So there we go. That's the steering mechanism for the Beast car. I've also done an initial idea for the cone as well. So that's what this model shows. If I hide the body, you can see that. So on this car, it's going to be a much more simple arrangement, where there's this part here that is fixed to the main chassis, so that doesn't move, and then this whole front axle subassembly is going to pivot about one central point. And again, I'm going to have to cut away the chassis there to give the clearance for that. Although some of that material was destroyed in the crash at ROSSA Round 3 anyway, so that shouldn't be a problem. Clearance to the bodywork looks okay on this. I mean, it's tight, but I'm only planning on steering before the run as I get into position, so at that low speed, if there's a tiny bit of rubbing, that should be okay. Yeah, so that's the plan for the steering then. I hope that made sense. My other plans then is to make my own flywheel based dyno. So this is my initial sketch for that. It's basically just a steel disc attached directly to my motor, and then the motor will be bolted to some solid block that I can clamp in a vise in my garage when I do the testing. And it's going to work by inertia to resist the acceleration of the motor in the same way as the mass of the car does. So this flywheel, I've sized it to represent a quarter of the mass of the car, but that makes sense because the car's got 4 motors, so each motor is doing a quarter of the work to accelerate the whole car. So that's my plan to simulate the resistance created by the inertia of the car. But then, of course, as I said in a previous video about the aerodynamic effects, those are extremely significant. So I also want to replicate that, and the fact that as the car doubles in speed, the aerodynamic drag is going to go up by a factor of 4. So the motors are going to have to work harder to allow for that. So the way I'm going to simulate that is to add some vanes onto that flywheel, which are going to cause a drag effect, which should, in theory, go up, say, you know, like I just said, 4 times for an increase in rotational speed of double. And it's worth pointing out again, this is a really early design, and my plan is to have this fully enclosed in a steel box so that if anything lets go when I'm doing the test, it'll be contained, because to reach my target speed we're looking at a rotation of around 20,000 RPM, which is gonna be containing quite a bit of energy at that speed. So I'm going to be making an appropriately sized steel box to make sure that that's going to be safe in the event of a failure. I'm pleased with the learnings I was able to take away from ROSSA Round 3. It gives a positive outcome to what was quite a difficult and unsuccessful event for me. I'm also happy with the concepts I've come up with for the steering mechanism for the Beast car. I think it's simple, but it should be stiff and durable enough to survive a speed run. Also, the concept I came up with for the test rig for the electric motor and speed controller, I think that's nice and simple, which is good for me because it means I'll be able to make it. And I've already got a new type of speed controller that I'm excited to test with that test rig. So I'll be trying to get that up and running as soon as possible. So my next few videos, that'll be about those aspects of the project and how they develop. And I'm also planning to make a special video which goes in depth into electric motors and how they work and how to select them and why might they be suitable for mine or your project. I've wanted to really unlock the mysteries of electric motors for a while, and I've been investing a bit of time into researching into them. And I've found out quite a bit that I'm excited to share with you all. If you could subscribe to the channel, you'll know more easily when these new videos come out. And I'd really appreciate the support for the channel. So thanks in advance for that, and see you next time.